Hello, everyone, and welcome to Elevating Multidisciplinary Transportation Projects through BIM 360. My name is Courtney Hawkins, and I am joined today by Stephen McDonald and Sean Hulbert. I am a transportation designer at AECOM Canada. I've been working in the transportation industry since graduating university 4 years ago. Although I'm relatively early on in my career, I've gained experience working on large transportation projects throughout Ontario. These projects have led me to develop a knack for finding workflows and tools to collaborate effectively with large teams. I've had the opportunity to work closely with our AECOM BIM team and Autodesk on recent projects, and together we found ways to improve our project coordination, which we'll be sharing today. And now I'll pass it over to Stephen and Sean to introduce themselves.
Thanks, Courtney. My name is Stephen McDonald, and I'm a BIM collaboration lead for AECOM in Toronto. I have 13 years of experience working with digital tools. My main focus in current times has been bringing projects forward to the cloud and refining collaboration methods to improve quality, increase efficiency, and elevate delivery. The adoption of BIM 360 as a platform to host our projects has been a major factor in our success as a project team. I am a keen proponent of the platform, and I love to explore the endless possibilities that are available to work with the design teams, the project management, and the project stakeholders. I believe that smart organization and effective communication is the key to ensuring projects run smoothly on the cloud.
Hello, everyone. My name is Sean Hulbert. I am a senior implementation consultant here at Autodesk, and I've been given the pleasure to work with the AECOM team on this particular engagement. I am a civil engineer in the state of Oregon with over 30 years of experience. I've joined Autodesk about 6 years ago, so a majority of my industry was focused on in practice in industry work. I have my passion is to get into the actual work projects and to assist my customers with making sure that they're successful with their tools. And I have, thank you, that's it.
Thanks, Stephen and Sean. So today we're going to be looking at an overview of hosting a project on BIM 360, which is a web-based cloud server that can be used to store project documents and collaborate with team members. Stephen and I have hosted several of our large transportation projects on BIM 360. With some help from Sean, we've been very successful with the execution of these projects and have noticed many improvements in our workflow. In today's class, we'll be focusing on project setup, document management, civil 3D projects, drawing creation, collaboration tools, model coordination, and then we'll finish with some general next steps and tips for hosting a project on BIM 360. So to start, I want to give a quick overview of the most recent project that we hosted on BIM 360, which is the Ontario Line South project. This contract included the civil and tunnel design of 6.7 kilometers of subway running under downtown Toronto. This includes 7 stations and 6 underground stations and 1 at-grade station, as well as 3 interchange stations to connect transit riders to existing subway and train services. I thought this would give a good understanding of the complexity of the project and the need for an effective workflow. Stephen, Sean, and I decided to team up on this presentation since we offer a wide range of expertise. Stephen is the BIM lead for the Ontario Line project, and Sean offers Autodesk support on the project, and I was the road designer for the project. So getting started with the workflow, the first step would be to set up a project in BIM 360, and this is fairly easy. The initial setup would be completed by the account manager. From there, the account manager can assign project administrators, and these individuals would manage the specific project on BIM 360 and would send out invitations to all of the project staff to join the project site. Once the team accepts the invitation, they'll be asked to sign into Autodesk and will be directed to the project homepage, which looks similar to the image on the slide. The project homepage can be customized to show some useful information. And next, so BIM 360 offers a wide range of services, but for this project, we only required BIM 360 docs. So in our case, users had two options from the project homepage: to navigate to document management or to model coordination. And we'll start with document management. And this is the tab where all the project files are stored. That includes contracts, background information, CAD models, and references, Revit files, PDFs, and Excel spreadsheets. BIM 360 allows you to edit Excel and Word documents on the website through a web version of Excel and Word. You can upload project files by either using the upload button or simply dragging files into the web page window. Here at AECOM, we have a standard folder structure that we start with, but from there it can be customized in BIM 360 to suit the project needs. BIM 360 automatically provides a plan section and a project file section, folder section, which I've highlighted in the image on the slide. The plan section is the area that we chose to store project documents that were ready for quality review, and Stephen will discuss this shortly. And the second section is called Project Files, and this is where we store all project documents and work in progress reports, CAD files, and Revit files. You can also set folder permissions for each folder, and it ranges from view-only permission to full folder control. All files in BIM 360 are version controlled, and this allows you to save and track the entire history of your design. And you can view and restore old versions, which can be a great tool for designers.
Thanks, Courtney. So this project was the first major project we had hosted all Civil 3D files and Revit files on the BIM 360 platform. As you can see from the screenshot on the right, Civil 3D 2021.2 accesses BIM 360 directly from the new home screen, bringing the user experience forward to match what the Revit users are used to experiencing. As we migrated to BIM 360, we were able to store our project design information on the cloud, our discipline designs files, data shortcuts, which included surfaces, track alignments, pipe networks, and pressure pipe networks, and reference files were also hosted to allow our design teams to show design information received from the client and the owners into their design files accurately. File maintenance was one of the most important aspects of managing our project, and this was identified early. Working with Autodesk, we mitigated errors on a weekly basis and increased our knowledge as a team as to some of the common reasons that may be causing us errors and sluggishness in our files. It was vital to our success that broken references were removed from our files being hosted on the cloud. We had experienced some file mismanagement where files linked from ProjectWise or local servers that had not updated the relative paths. This was a major issue for Desktop Connector, but utilizing the Reference Explorer and expanding the team's knowledge, we were able to easily identify and fix problematic files. Regular cleaning of the files was another important tool we used to increase our file efficiency on the cloud. Purging reg apps was a major tool we used in our success story. Also, regular purging and auditing files ensured no files were slipping in terms of cleanliness. It was also important we had a rigorous routine of cleaning any inherited files from the client or vendors to ensure that what we were posting to the cloud was fit for purpose. You would be amazed at some of the stuff we found in the background of the files that were being sent to us. However, a very quick process using batch save allowed us to ensure everything was up to standard before being posted to the cloud for the design teams to reference.
So next is drawing creation. And we found that it's very important to set up standards for drawing creation at the beginning of your project and to make sure that all designers are following these standards. That includes naming convention. Since BIM 360 is version controlled, it's important to keep the drawing names the same throughout the project. CAD model files should be created from a DWT template file. And this template can be set up to include shared coordinate systems for the project, standard fonts and styles, and as well as standard settings. In terms of sheet files, it's important to set up a standardized title block for the entire project. If this is done, then you can use the OCR reader in BIM 360 to automatically fill in the PDFs. This means when a PDF drawing is uploaded to the plans folder, the reader will automatically populate the drawing attributes, such as the drawing name, the description, or revision number. Another tip is in this page setup in Civil 3D to turn on the display plot setting style or display plot styles, which I've highlighted in the image on the side. And this allows the CAD sheet file to be viewed directly in BIM 360 without having CAD installed. And this was a big time saver for me as a designer. It meant that I could save time plotting drawings and saving them to PDF. Finally, when designers create 3D models, they were asked to create data shortcuts. And these data shortcuts were all saved into one folder on BIM 360 and available for all disciplines to reference into their models. Designers were also asked to share all 3D models in the model coordination space, which we will discuss shortly. And we did this by creating container files, which are essentially files with data shortcuts instead of using the actual models. And this reduced the size of the file and increased speed of our 3D models. So for these types of large transportation projects, we work closely with our Revit counterparts. In our case, we had architectural, structural, mechanical, electrical, and ventilation designing in Revit. With a project team this big, it's important that we coordinate our models well, and we achieve this by setting up a shared coordinate system for all the disciplines. I've added a few images onto the slides of tools that we use to produce these shared coordinate systems in Revit and Civil 3D. Then on a weekly or bi-weekly basis, depending on the project needs, the Revit team would produce an export of their files in DWG format. And this was an easy process once the Civil team and Revit teams had coordinated and set up saved views in Revit. The Revit teams were asked to keep the name of the exports consistent during the duration of the project. And then these saved views would be exported to DWG and shared with our Civil teams to a specific folder on BIM 360. In our case, these Revit exports were being used by our track, road, landscape, utility, and drainage teams. The Civil team was able to use the check reference tool, reference status tool, which I've also highlighted on the slide, to confirm that they were always working with the most up-to-date version of the references. Another great tip is that you can subscribe to folders in BIM 360, and this means that every time someone uploads a new file, you get a notification, and I found this to be a great tool to notify me when disciplines had made a change, and then I could go in and change my drawings accordingly. And then one of the main locations for coordination between all the disciplines is model coordination, which we will talk about shortly. But first, I'll pass it over to Stephen to talk about collaboration tools.
So we utilize the functionality of the cloud and the tools in BIM 360 to conduct reviews in an online environment. PDFs that were posted to the plan section of BIM 360 were used in meetings to discuss project design issues, and markups were created on the PDF drawings. Internal quality reviews were conducted across a variety of sub-consultants, and permissions were managed by the BIM management team to ensure the project security was being managed correctly. Another useful part of hosting our Civil 3D files on BIM 360 is designers could make changes to their drawings and send a link to discipline leads to view and mark up the drawings in the DWG itself, which removed the need for endless printing of sheets. This functionality also meant someone without AutoCAD on their computer could open and view the files, therefore reducing overhead costs to the project. The issues function was something we had delved into and utilized a lot on this project. In the beginning, we used it as a collaboration tool for requesting information between the design team. The issue would be open. When a response or a document was provided, the status would change from open to answered. And when the originator was happy with the response, the issue would be closed. Email notifications from issues was a really useful tool, and allowing users to manage whether they received notifications instantly, hourly, or daily proved to be wise to not flood certain team members with emails. Utilizing the activity log in the issue itself was invaluable for tracking all actions and changes within the issue, and the historical log could never be deleted. We ended up utilizing this tool and customizing attributes to help communicate and coordinate with our client, so design teams could respond to comments on our technical documents. All information could be easily exported to Excel for review and for records, and it kept a live database of all comments that can be tracked to closure. Versioning control was also used widely on this project, mainly checking between versions of PDF drawings to easily identify what had changed and allow discipline leads to sign off on drawing reviews much faster.
Model coordination in BIM 360 is where users can view 3D models. 3D models such as surfaces, utility pipe networks, and Revit models can all be published to model coordination and can be viewed in one place. So in BIM 360, under model coordination, you can see a list of all the models that have been published. So you have a couple options, and the first one is just to view an individual model. In this case, I've selected a 3D pipe network, and you have a series of tools at the bottom of your screen. And one of these tools is properties. So if you select an object on screen and hit properties, you can see a full list, a list of information about the object. In this case, it's a 100mm PVC water main. Your other option is to use the measure tool. So I can see it's a 3.2 meter pipe. And then you have a few other options, which are pan and orbit. And it just gives you a different view of the 3D model. And then if you exit out of this, your other option is to view multiple models at once by either selecting from the list or going to the saved views at the side. And in the saved views, you can save a bunch of models that you want to view together. So I've opened the saved view, and you can see the surface, you can see the station from ground level to tunnel level, and you can see a series of pipe networks. And in here you have the similar tools at the bottom, but you also have options at the side, and one of those is to create an issue, and you just hit the create issues at the bottom. So in this case, if I wanted to point out a conflict in the design that I want the designers to be aware of, I would create the issue, tag the designer, and they would receive a notification that something needs to be fixed. Your other option at the side is to view clashes in your model. So if I were to hit that, this is what comes up, and you have the option to choose a model that you want to check clashes with other models. So in this case, I've just chosen the architectural and the utility models. And then you see highlighted in red and green, these are all the conflicts in the design currently. So I can see that there's an existing pipe that's in conflict with our station and will need to be relocated. Same thing, you have tools at the bottom to measure, check properties, orbit, and pan. And then your other option in model coordination is to view a list of clashes in a table format, which you can see on the screen, and it will show you the number of clashes between different models. And if I were to select one of them, it automatically shows a 3D view of where this clash is located. And this is a great tool that we used throughout the project to coordinate between all the disciplines. And over to you, Sean.
Thank you, Courtney. So one of the important things that we learned early about this particular effort or this particular workflow was making sure that we were setting ourselves up for success in the very beginning. It's critically important that we have the correct versions of software on our machines and that we're all using the same versions of software, specifically of Desktop Connector. The other thing that we realized is that preparing the data was also critical for our success in making sure that we checked the drawings for errors, removed any unused information or data that was attached to the drawings, all including redundant information. And then, like Stephen alluded to earlier, we leveraged the Autodesk batch save utility to make sure that we were running clean, or to run a clean Lisp routine on that to make sure that the drawings that we were uploading were cleaned. We also used that utility when we received any new files from subconsultants that were not put up into BIM 360 by that particular team. We would clean these files and ensure that they also were loaded into BIM 360 in the best format that we could get them in. We also looked at options for migrating data. Early in this particular project, we used the manual migration method, but during the project, Autodesk released a tool for migrating projects to Civil 3D, and I'll give you a little preview of that tool here in just a moment. And then the last thing that we realized that we wanted to make sure that we documented well were the troubleshooting processes. Autodesk released with the 14.10 version of Desktop Connector, we released a tool called Reference Explorer. We'll also do a quick demo of that here in just a few moments. Reference Explorer gives us the opportunity to unwind any of the dependencies which may not be in the area they should be for BIM 360 to function in its optimal performance. And then the other thing when you're with the troubleshooting process is from time to time, we end up where we think we may have misplaced, or for lack of a better term, we have lost data. I can assure you that in over a year and a half, almost 2 years now, I don't think we have lost any files per se, or even a significant amount of time, because we were able to find those files in our temp directory inside Windows. So what you'll see here is the %temp%. If you put that in your address bar in File Explorer, it will take you to a temporary location where if you do not have the most current version of your drawing up in the cloud, you will likely find the most current version here in this temp location. And so as you'll see on this next slide that we're going to open up, we're going to talk about leveraging the the data migration tool for Civil 3D. And within this video, what you're going to see is I'm going to a local project location, can either be on your local drive or on a server, and we're going to select all the files that are within that project. We're going to use our data exclusion tab to remove anything that we don't want to upload to the cloud, such as BAK files, error files, etc. Now what we're doing is we're checking the integrity of the data. Desktop Connector is evaluating these files to find out what dependencies these files have. And if any of the files are missing, we get the opportunity to resolve those missing files. If we have any circular references, we get the opportunity to understand what these circular references look like. And then we can also take the efforts as needed to resolve those references. We even get a nice little image here to show you what files are attached to the drawing that is indicated it may have a circular reference. So here we go. You'll see that this particular cover drawing has an X reference attached to it, and the grading drawing has a number of references attached to it. The Reference Explorer tool do a very similar task for us. And so the next step now is to go back through the integrity of the files, making sure that everything is ready, and then we start uploading. This will kick Desktop Connector off, and Desktop Connector will be moving massive amounts of data up to the cloud from your machine. So what it's literally doing is copying it from the location that you're saying the data is stored in, either locally or server, moves it over to the desktop or the Autodesk Drive location, or excuse me, Autodesk Docs location, and then pushes that up to the cloud for you. And then you also get the opportunity to view a CSV file, which will give you all the information about the files that it pushed to the cloud, as well as the data on the references that may be broken. And so now that we've moved our data to the cloud, we may run into some scenarios where we need to check that information. And so on the next slide, what you'll see here is that this is our Reference Explorer tool. Now, one thing I forgot to mention on the previous slide, The data migration tool is available at feedback.autodesk.com and will likely be in the App Store very soon. And so what you're going to see here on this particular video is we're going to use the Reference Explorer tool to actually unwind some of the dependencies that are in our Autodesk Docs directory. So we'll navigate in File Explorer to our project, and we'll find the files that are in question. We'll want to make sure that we right-click on those files and synchronize those files so we have the latest and greatest. If they're online, it will not dive into the file. They do need to be synchronized. And then we'll right-click on Desktop Connector and go to the Reference Explorer tool. Again, that was released with the 14.10 version of Desktop Connector. And so now you can either use the Browse for File or Open option to add those files to Reference Explorer, or my preference is just to drag and drop. So I'll drag and drop our street plan in here. And what you'll see is it'll start to tell me as soon as it's analyzed the dependencies in this file, Desktop Connector is doing its job right now. It'll show you all the references that are missing in that particular file. It starts out with a list view here for us, but if we go up to the tree view, we could start digging even deeper into those the files that are missing those particular references. So the street plan may not be missing any references per se, but one of the dependencies in the street plan is missing a reference. And that's what we're doing here is we're going to minimize this list and find out exactly where those drawings are looking for a W drive, and they should be looking for our ACC docs location. And so with the Reference Explorer tool, what you have here is you now have the ability to unwind your own say network room, so to speak. It's kind of a mess of wires that we've now unwound, and we've got everything working in the correct way. And this ensures optimal performance within BIM 360. And so on our last slide, or on the next slide here, what we're going to see is that we've got a list of best practices and just some reference material for you when you're actually pushing your project up to the cloud or even starting your project in the cloud. So there's a couple of documents around the collaboration for civil. We also cover best practices for migrating. Again, there is a manual method, but I would highly recommend you use the migration tool. And then always remember that Autodesk support is here for you. So if you do run into any deltas, please don't hesitate to reach out to the support team at Autodesk, and we'd be more than happy to get you some answers. But I think the lessons that we learned as a team here was that clean drawings are friendly drawings. Clean drawings are friendly drawings, whether they're in the cloud or on a server. It doesn't matter what cloud environment they're in, they will be happier if they're clean. And then open communication with your team. Chat, ask questions. Don't be afraid to ask questions, because the only stupid question is the one that does not get asked and causes you, the rest of your team, some pain points. And again, team, collaborate internally. We call it collaboration for civil for a reason. It's so we can all work together. Don't hesitate to just open up and ask some questions, reach out to your team. You probably have a teammate who is either having the same delta or had it and knows how to fix it. Courtney?
Thanks, Sean. Those are all very useful tips that have definitely helped Stephen and I with our BIM 360 experience. So thank you everyone for joining our class, and we're hoping that everyone that participated now has a better understanding of how to successfully host multidisciplinary projects on BIM 360, how to improve collaboration across multiple Autodesk products such as Civil 3D and Revit, understand best practices for optimizing BIM 360 performance and maximizing user experience, and have a better understanding of workflows for hosting Civil 3D projects, Civil 3D and Revit projects on BIM 360. So we have created a second class that will be included in the 2021 Autodesk conference, and the title of this is Bringing the Underground to the Cloud. So please join us for an overview of why we chose BIM 360 for many of our transportation projects. And thanks to everyone that joined. We hope you enjoyed, and we'll be happy to answer any questions about the presentation.